Next, 1D. 1D, right? See, already out of 6, right? Out of 6, I will write separately. Ux, Uy, Uz. Theta x, theta y, theta z. Okay, right. Now, what are the 3D cases? 3D cases, compulsory 3D cases. Uz 3D, theta x 3D, theta y 3D. Okay, right. What are the 2D cases? Ux 2D, Uy 2D, theta z 2D. Right. Now tell me, which is related to 1D? 1D. See, 1D means Ux alone. Sorry, x alone is 1D. Okay, sir. Y alone is 1D. That is also okay. Z alone is 1D. That is also okay, right? But which one we can take it for a study purpose? First preference. X, Y, Z. In general. X alone is 1D, Y alone is 1D, Z axis alone is also 1D. Right? Which axis will be considered for first preference to represent 1D, one dimension? X or Y or Z? X only, right? X only. First preference is for X only, right? So we will consider X for 1D, right? Now tell me, out of the 6, just imagine, already you know how to draw the arrow marks for all the 6, right? Which motion will take X axis along, or which arrow mark can be drawn only with the X axis, without the need of Y direction and Z direction, without the need of Y direction and Z direction. Which motion can be drawn without the need of Y direction and Z direction? So these are all already out, right? 3D, not even 2D. So don't think about these 3. Out of the 2D, 3 things are there. Think about one by one. To draw this Ux, do you need Y axis, Z axis? Answer. To draw this Ux, whether you need Y axis and Z axis informations? No need. So Ux 1D. Ux is 1D. Now, to draw the Uy, do you need Y direction or Z direction informations? Yes or no? No. Without knowing the Y direction information, you can draw Uy. Yes. Right? So we need Y direction information, right? Then only we can draw Uy, right? So Uy is 2D. Right? Now theta Z. Right? To draw the theta Z, X axis alone is enough to draw the theta Z circle. X axis means this is the X axis. This line is alone enough? No. So theta Z also 2D, right? So 1D case is only Ux. Okay, right. Only Ux is 1D. Ux only. So I will write the informations one by one. Degrees of freedom. So notice carefully, everyone. First, degrees of freedom. UX, UY, UZ, theta X, theta Y, theta Z. Okay. Now tell me, to create UX in the object, to create UX in the object, what will you apply? What will you apply? For example, there is a duster in the classroom. I am asking you, create UX in the duster. It means move the duster in the X direction. Move the duster in the X direction. X direction. That is my order. Right? What will you do? What will you apply on the duster? What will you apply on the duster? I am asking you to create translation. What will you apply?
We have to apply force.
Very good, very good, very good. Force you will apply. See my question carefully. Create the displacement along X direction. Create the displacement along X direction. That is my order. Now tell me your answer. Your answer is, sir, I will apply Fx, sir, Fx. Force along X direction, sir. Okay, that is a correct answer. Right? Force along X direction. Very good. Fx. Right. Now, I am asking you to create Uy in the duster, in the object. What will you apply? What will you apply on the object? Force along Y direction. Force along Y direction. Right. Right. To create UZ, we will apply force along Z direction. Right. Now tell me, what is a unit for load? Unit for load. Answer. Unit for load.
Newton.
Okay. Let us check. Very good, very good. Next, we have to create rotation about x-axis in the object. Rotation about x-axis in the object. Right. What will you apply on the object? What will you apply? For translation, you are applying the force. For rotation, you will apply torque is okay, but general name. Moment. General name is moment. Right. Either the moment may be bending moment or twisting moment. Right. Twisting moment has a special name, torque. Okay. Right. So the answer is, sir, I will apply moment about X direction, sir. Moment about X direction. To create theta Y, moment about Y axis. For theta Z, moment about Z axis. Right. Okay. Right. So in general, moment about Z axis is represented as torque. Okay. Right. In general. Right. See the second column, right? First column is degrees of freedom. This is first column, degrees of freedom. The second column is called as loads column. Loads. Right. Now tell me, what is a units for load? Unit. Watch the column carefully. Tell me the unit. All are loads. All are loads. Now tell me the unit. Newton. Unit. Everyone has to answer whether it is correct or not. Different. That is not a matter. Newton, comma, Newton meter. Okay, right. Sir, out of the two types of loads, right? This is force load, this is moment load. Which is critical, sir? Moment load is very, very critical. Moment load is very, very critical. Right. The reason is, as a fresh engineer, you can design the component to withstand the force easily without mistake. Right. But designing the beams or columns or shafts to withstand the bending moment or twisting moment is very, very tough job. Right? So we will design, but without our knowledge, failure will happen in the object. Right? So something happens unexpectedly. Right? So design against the moment load is somewhat tough comparing to design against force loads. Okay. Right. So moment loads are critical. Right. Now, what do you mean by equilibrium? What do you mean by equilibrium? Any idea? Equilibrium. I think you are watching my definitions. All the definitions will be very simple and sharp, right? In the interview, you have to answer the same thing, right? What do you mean by equilibrium? Any simple idea? Equilibrium. So it is an interview question, right? Equilibrium, equation, equilibrium is a very, 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 very important topic. You have to give your opinion. What do you mean by equilibrium? Net force is zero. Very good, very good. Net force is zero. Right? Answer is correct. Next, another type of answer I am expecting. Net force zero is correct. Next, other students, please answer. No movement. Very good, very good. No movement. That is also correct answer. Next. Next. Both are correct answers. Next. Very good. Just give me your idea. Net force and moment is zero. Very good. Excellent answer. Net force and moment both are equal to zero, sir. Very good. Very good. Right. Let us see. Right. Equilibrium means, right? No linear acceleration, no angular acceleration. Very good. That is also correct. Forces are in opposite direction. That see, all the answers are individually correct. Okay, right. So the Ajit told, right, that is a very close answer. Right, I will tell. Right. Equilibrium means. Right. Let me tell one thing. There is a duster in our classroom. I kept in the table, first table. We are all went for break. After the break, we are seeing the duster. The duster is moved in the x direction for 0.1 mm. The duster moved in the x direction for 0.1 mm, right? 0.1 mm, right? It is not moved in the y direction. Means uy is 0. Similarly, no movement along the z axis. No rotation about x-axis, no rotation about y-axis, no rotation about z-axis. Only displacement, that to 0.1 mm in the x direction, along the x direction. Now tell me the duster is in equilibrium or not. After the break, we are watching. This is happening, right? It is in equilibrium or not? Yes or no? That's it. Sir, yes, sir, it is in equilibrium, sir. The duster is moved in the x direction. It is not moved in the y direction, not moved in the z direction. It is not rotated about x axis, not rotated about y axis, not rotated about z axis. No, it is not in equilibrium. It is not in equilibrium. Okay, it is not in equilibrium. So when will you accept that it is in equilibrium? When will you accept that it is in equilibrium? When will you accept that the object will be in equilibrium? Now you are not accepting this situation as is in equilibrium, right? Tell me. Ux also 0. Sir, if Ux also 0, then I will accept that it is in equilibrium, sir. That is what you are saying, right? Now tell me the overall answer. Overall answer. When will you accept that the object is in equilibrium? When will you accept? If, sir, I will accept the object in equilibrium if tell me. Right. The movements in all the directions is 0. Excellent answer. Movements in all the directions is 0. Very good. So if all the degrees of freedoms are 0, if all the degrees of freedoms are 0, then I will accept that the object is in equilibrium. Correct? Right. Compulsorily all the degrees of freedom must be equal to 0. 3 displacement, 3 rotations must be 0. Right. Now tell me, there is an object. There is an object. Right. One force is applied. One force is applied on the object. Right. One force is applied on the object. Right. Force F or force P. Right. But still I am saying that still the object is in equilibrium. One force is acting. Still, I am saying that after checking, I am saying that the object is in equilibrium. After checking only, I am saying. Okay, right. What is a possibility? What is a possibility? There is an object, one force is acting. So I am checking the ux, uy, uz, theta x, theta y, theta z. After checking, I am saying that object is in equilibrium. Right? What is a possibility? The force must be equal to 0. The force must be equal to 0. Right? Right. So the force must be a dummy force. Or null force. Null force. Okay. So it is called as one force equilibrium. One force equilibrium. One force equilibrium. It's called as one force equilibrium. Very, very, very important topic. It is very much useful in the truss chapter, trusses chapter. Okay. Right. One force equilibrium. Right. So I will give the hint now itself. Right. T joints. T joints. T joints. So T joint means everyone watch carefully. T joint means two forces will be in line, right? For example, like this. Two forces are in line. Okay. Right. So this is a joint. The circle is a joint. Okay. Right. It is a joint. There are three forces acting: P1, P2, P3. Okay. Right. So this type of joint is T joint. Right. What is the condition I told? Two forces are in line. These two forces are in line. There will be a third force, but I did not tell the orientation about third force. It need not be perpendicular. It need not be perpendicular. Okay. Right. It may be at 89 degree or 91 degree or 70 degree, 15 degree, 20 degree, anything, right? But not in line. Right? Two forces are in line. One force is not in line. Right? I will draw another type of T joint. Okay, right. Same P1, P2, P3. We can give any name: T1, T2, T3, or in any order you can give, right? Or you will give the different order for understanding. This is 2, this is 3. Okay, right. Now, which two forces are in line? What are the inline forces? What are the inline forces? Inline forces. P1 and P3. P1 and P3 are inline. These two are inline, sir. Correct, right? P2 is not inline. Okay, right. So in this type of situation, see what I'm trying to say, the force which is not inline need not be 90 degree. It may be at any angle. Okay. For example, like this, right? When we are applying the force in this direction, that force will be received by this member directly. Whatever may be the force applied, right? It will be directly flowing through the same inline path, right? It will not be splitted in the other path, right? It means what will be the force in the P3? What will be the force value? P3 value here? 0. It will be equal to 0. Okay. So this value and this value will be equal. All the P1 will be transferred to P2 fully. Similarly, here which will be 0? Which is not inline. Which will be 0? That means which is not inline. P2, right? Here it is equal to 0. So the force which is not inline is equal to 0. Okay. This is the shortcut actually. It is a shortcut. Because in the recent year questions, GATE questions, mostly in the civil engineering, right? They are asking us to identify the zero force members. Zero force member. Many questions are asked. Zero force members, right? So this is the only way to identify the zero force members or dummy members. Okay, right. Then I will draw other types also. T joint need not be horizontal, it may be in the vertical direction also. T-joint concept means compulsorily 1 mark or 2 mark will be there in the GATE examination for both departments. Okay. Let us say it is P1, P1, P2, P3. Now tell me here which is 0? Which is 0? P1 is equal to 0. Okay. Right. Now let us say this is P2, P1, P3. Here which is 0? P2 is 0. Okay. Right. In the examination, they will not say P1, P2, P3. They will say A, B, B, C, C, D, like that. Okay. Joint names they will give. Right. So T joints. So T joints means two forces will be in line, one is not in line. Two forces are very, very, very important information. Shortcut actually. Two forces are in line. And third force is not in line. Third force is not in line. This is the information related to T joint, right? So this P3 equal to 0, this P2 equal to 0, P2 equal to 0, P1 equal to 0. So these members are not in line with the other two forces. That is why we are saying 0. So how do you say that it is 0? These are all based on the one force equilibrium. One force equilibrium. Right. One force equilibrium. Sir, how, sir? Right. The reason is all of this here. Right. Here, what is the net effect in the x direction? Net effect in the x direction? Net effect in the x direction. Already I told this full force will be transferred to other side, right? 0, 0, right? See, in the x direction, no movement. X direction, no movement. Ux will be equal to 0. Left side, P1 100 Newton means, left side 100 means, P2 also 100 Newton, right side 100 Newton. So net displacement or net effect in the x direction is 0. Right. How many forces in the y direction? How many forces in the y direction? Only one, right? Only one. Okay. But still the joint is in equilibrium. Still the joint is in equilibrium means, right? Or if you want the joint to be in equilibrium, what should be the value of this force in the y direction? Y direction uy to be 0, then only you will accept that it is in equilibrium. Okay. So this force must be 0. It must be 0. Okay. Right. That is why we are calling it as a one force equilibrium. Sir, inclined means, sir, directly these two will be cancelled each other, nullified. Right? Same effect, but in opposite direction. Same magnitude, opposite direction, same line of action. Okay. That is called as two force equilibrium. Right? but it has both x direction as well as y direction. Okay, right. What should be the, or how many forces are in the y direction for this joint? How many forces are in the y direction? Only one, this one. Okay, this one, right. But still I am saying that the joint is in equilibrium. It means what should be the y value? This Fy value, zero. It must be equal to 0. Okay, right. Now think, if this Fy is 0 means, okay, right, what should be inclined? Inclination is compulsory. It is sure, 100% is sure that it is inclined, right? For the shearly inclined line, if the y value is 0 means what should be the x value? That is also 0. Net resultant value, that is also 0. Okay, right. So that is why we are calling it as a one force equilibrium. Okay, in all the cases. So T joint means one force equilibrium. Okay, right. Sir, only one force means we can say that is dummy force. Okay, sir, I accept. Right. If two forces are acting, see, this slide is for one force equilibrium alone. Okay, very important slide. Now there are two forces. Acting on the object. Right. But I am saying that, see, two forces are acting on the object, but I want the object to be in equilibrium. What will be the expected condition? Tell me. What will be the expected condition? I want the object to be in equilibrium. Equal and opposite forces, that's all. Equal and opposite forces, very simple. Right? So P1 is equal to P2, but in opposite direction. Okay. Right. So magnitude of P1 is equal to magnitude of P2. Right? If you say with direction, P1 is equal to minus of P2. That's all. Right? So same magnitude, opposite direction, same line of action. Same line of action. If you satisfy all these conditions, all these three conditions, even though two forces are acting, still we can expect that the object will be in equilibrium. Right? It is called as two force equilibrium. Two force equilibrium. Two force equilibrium. Okay, right. Now there are many forces. Acting on the object. Many forces acting on the object. Right. Right. For example, n number of forces in the positive x direction. 3 forces, for example. 2 forces right side, 1 forces left side. Right. P1, P2, P3, P1, P2, P3. All are acting in the x direction. In the same times, 2 forces are towards right, 1 force is towards left. But my expectation is I want the object to be in equilibrium. I want the object to be in equilibrium. What is the expected condition? What is the expected condition? Okay, P1 plus P2 is equal to P3. P1 plus P2 equal to P3, right? Suppose 5 number of forces in the left side, 7 number of forces in the right side. Hence, the equation will be bigger. Right? How to write it? Simply how to write it? Shall I write summation of fx equal to 0? Shall I write like that? Algebraic sum of all the forces along the x direction is equal to 0. Shall I write like that? Yes, we can write. So the summation symbol will take care of sign. Right? Right side means positive, left side means negative. Automatically, the sign will be taken care by the symbol. Okay, right. So multiple force equilibrium. Okay, right. In the x direction, right. Now come to our main condition, right. So I want the object to be in equilibrium. It means ux to be 0. Already you only told, right? Sir, uy 0, uz 0, theta x 0, theta y 0, theta z 0. Then only I will accept that the object is in equilibrium, sir. Okay. So in order to satisfy ux to be 0, either one force is acting or 2 forces are acting in the x direction or n number of forces are acting in the x direction. Okay, right. I don't care. I can say that summation of fx equal to 0. Right. If I satisfy this condition, what will be the ux value? What will be the ux value? 0. Right. Similarly, in order to get uy to be 0, summation of fy is equal to 0. For uz to be 0, summation of fz is equal to 0. Summation of mx equal to 0 for theta x to be 0. Right. Then for theta y to be 0, summation of my should be equal to 0. If you want theta z to be 0, summation of mz is equal to 0. Right. If you are satisfying these 6 conditions, right, what will you get? All the 6 degrees of freedom is equal to answer quick, don't get delayed. 0. Right. If all the 6 equations are satisfied, I will get all the 6 degrees of freedom equal to 0. If all the 6 degrees of freedom are equal to 0, the object will be in equilibrium. So we are going to give the name for these 6 equations. These are all called as equilibrium equations. These are all called as equilibrium equations. Okay, right. So this is for 3D, right? Now tell me how many equilibrium equations are there for 3D? How many equilibrium equations? 6, right? 6 degrees of freedom, 6 loads, 6 equilibrium equations. Right? the 6 equations can be grouped into how many categories? Tell me. See the 6 equations. Tell me how many. Very good. 2 groups. What are the 2 groups? Force equilibrium and moment equilibrium. Force equilibrium and moment equilibrium. Already you know, right? You know the answer. In the particular object, force equilibrium equations are satisfied, but moment equilibrium equations are not satisfied. Any one of the moment equilibrium equation is not satisfied. It means the object is in equilibrium or not. No, it is not in equilibrium. It is not in equilibrium, right? So when will you accept? Sir, all the force equilibrium and all the moment equilibrium must be satisfied. Then only I will accept that the object is in equilibrium. Okay, right. Now we will go for 2D. 2D. Same method, directly we can write the answer, right? 2D. How many degrees of freedom for 2D? Answer quick. Ux, Uy, theta Z. Ux, Uy, theta Z. Loads are Fx, Fy, Mz. Right. Then see XYZ orientations are given by us only, right? There is no compulsion to give this as a X, this as a Y. It is not a compulsory one, right? This can be given as X. It can be given as Y, right? Only condition is X, Y, Z are mutually perpendicular. That's all. Okay. Depending upon the given problem, we can orient the XY axis, right? It need not be exactly horizontal and vertical, right? And equilibrium equations, summation of Fx equal to 0, summation of Fy is equal to 0, summation of Mz equal to 0, right? This is for 2D. Now for 1D. For 1D. How many degrees of freedom for 1D? How many degrees of freedom for 1D? Only one. Ux only. The expected answer is Ux only, sir. Right? Ux. Load is Fx. Equilibrium equation, summation of Fx equal to 0. That's all about degrees of freedom, loads, equilibrium equations for 1D, 2D, 3D. So, is it clear? 1D, 2D, 3D, degrees of freedom, loads, equilibrium equations. Is it clear? Right. Now, I will give the simple explanation for equilibrium. Equilibrium means what? Sir, all the 6 degrees of freedom is equal to 0. Then I will accept that it is in equilibrium, sir. Right? So let us say that equilibrium means no change in state. No change in state. No change in state. It means what? Ux equal to uy equal to uz equal to 0, theta x equal to theta y equal to theta z equal to 0. Okay, that is the meaning of no change in state. Okay, next. So we will discuss about moments, types of moments. Okay, types of moments. See, don't think it is a direct engineering mechanics information. It is used for further SOM and structural analysis, theory of failure, machine design, everything. Okay, right. So this is a 3D object. Okay, we will give axis or x-axis, y-axis, z-axis, right? So let us assume that left end is fixed. Left end is fixed. Left end is fixed. Okay. See, we are going to discuss about moments only, not about forces. Moment only. Right. Effect of the moments. Okay. Right. See, I am expecting the exact answer without oscillation. You can take time, but answer should be exact one. See, I am applying the load, point load here, right? What is the name we can give? This one F. What is the name we can give? X or Y? Y. Very good, very good. Fy, right? Fy, right? Fy. Then another force in this direction. Okay. Now, what is the name we can give for this? Huh? FZ. Okay, FZ. Right. So these are the loads, right? These are the point loads. Point loads we are giving. Right. Now, due to Fy only, it means vertical downward load. Due to vertical downward load, right? This member will bend or not? This member will bend or not? This member will bend or not? Yes, it will bend, right? Now the question is, answer should be correct one. Right. About which axis the beam will bend? Answer should be correct. Think practically, tell me, right? Due to Fy, about which axis the beam will bend? Axis, about which axis? Z axis, about Z axis. Okay, right. So it means it will bend like this. Okay, the bending will be like this. Okay, right. So about Z axis it will bend. About Z axis. Right. See, you told that Z axis bending. See, after some time, I will remove the names X, Y, Z and all. After some time, I am going to remove. Okay, right. First, just for understanding purpose, I am asking, right? Beam will bend, sir, about Z axis, sir, right? Okay, right. Due to this load, FZ, right? The member will bend or not? The member will bend or not? Yes, yes, right. Tell me correctly without mistake. About which axis it will bend? Very good, very good, very good. Super. About Y axis, sir. Right. Y axis. Y axis. Right. About. 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 Right. It is also called as bending. Okay. Right. Next. See, rotation about Z axis, rotation about Y axis, right? The beam rotates about Z axis, the beam rotates about Y axis. You told that it is bending according to the given diagram. According to the given diagram. Right? If the rotation takes place about X axis, if the rotation takes place about X axis, the beam will bend or not? The beam will bend or not? Think practically, tell me. If the beam rotates about X axis, the beam will bend or not? No, it will not. It will not bend, sir. It will not bend. Then what will happen? Rotation about X axis is done by you only. You are very good, very good. Twisting, sir. It is twisting, sir. Very good, very good, very good. Super, super answer. Right? Theta x about x, right? See, the x, y, z's are artificial. It can be at any place, right? It's not a matter. It is called as twisting, right? Right? Now we are going to generalize it. We are going to generalize it. Take cross section. Take the cross section. This is a cross section. This is the cross section. Okay, right. What are the axes? What are the axes along the plane? What are the axes perpendicular to the plane? That is the question, right? So along the axis, right? Along the plane, right? The axis along the plane are called as in-plane axis. The axis perpendicular to the plane are called as out of plane axis. Out of plane axis. Now tell me, what are the in-plane axes? Y and Z. Y and Z, right? Very good, very good. Y and Z. Okay, right. Which is out of plane axis? X, right? X, right. Now tell me, the rotation or moment, right? Moment about in-plane axis are called as which moment? See the name correctly, then tell me. Moment about in-plane axis are called as which moment? Bending moment. Very good, very good. Bending moment. It is nothing but moment about in-plane axis. Okay, right. If the moment is about out of plane axis, it is called as which moment? If the moment is about out of plane axis, it is called as twisting moment. Very good. Twisting moment. Twisting moment. Moment about out of plane axis is called as twisting moment. Okay, right. So simply saying, right, remove the X, Y, Z names, right? Let us say 1, 2, 3. One, two, three, right? Let us say this is 1. I'm changing, purposely I'm changing. 1, 2, 3. Right. Now I'm giving the 1 and 2 for in-plane axis. 1 and 2 for in-plane axis. 3 is for out of plane axis. 3 is for out of plane axis. Purposely I'm giving. Okay, right. So rotation about 1. Rotation about 2. Both are called as bending moment. Right. Rotation about axis 3. It means out of plane axis is called as twisting moment. Okay, right. So general information is moment about in plane axis are called as bending moments. Moment about out of plane axis are called as twisting moments. Right.